Good afternoon. I hope you all enjoyed the break. I'm Peter Sommerlad, professor in Switzerland, and I'm designer of these hats. I know some of the audience have a hat, and I have 6 spare hats that we will give out tonight for the tool time session at 8 or 8:30, somewhere in this building. So let's take that off. Scope guards and unique resource. 5+ years in the making. I think this is one of the features that should be in the standard library that everybody would like to have, but it's very hard to actually make and get it past the reviewers in the Standards Committee. And this is a story about that. I will have some code that is simple and easy to follow, and some code that is just too much to get on a slide. So don't expect to understand everything that's on the slides. I might not either. What is a resource? Some of you might know, but not everybody, that I have a history before C++. I'm an author of pattern books, not of this one specifically, but of the starting of that series. And patterns are about successful engineering. So a lot of things that you hear at conferences like this are stories about successful or maybe not so successful engineering. And patterns are stories about successful engineering. Who owns a pattern book? I always like to know my audience. Who owns more than one pattern book? Okay, there are plenty. Not all of the pattern books have patterns in the title, but there's one on resource management, and then what you can see here is a kind of the map of the patterns of that book. I don't want to go into that detail, but the biggest thing is you need to understand is a resource is something with a lifetime. It usually you need to acquire the resource, then you use it, and you release it again back to what this book calls the resource coordinator or resource manager. Some resources are given to you by the operating system, like a file handle, or by the runtime system, like memory. Or you might have resources that you manage yourself, and you have things like manager objects. And there's a resource manager in that book, and I also wrote a pattern on managing objects. Resources can be exclusive or shared, and the shared part is interesting, especially like a thing like memory. If I have many people or many threads or objects in the program sharing a whole global heap space, that can be contentious, and you end up having problems if you run, if you don't manage the life cycle correctly. And usually not releasing a resource can be an error. Now, who has programmed Java or C# seriously in his or her life? There, especially the students that I deal with that start out with Java, they don't get the, let's say, the feeling that they manage resources. When they write new, it's just they have to. They don't understand that they grab memory from a global heap that somehow by magic is released when they forget about the objects, if they do it correctly. But even in Java, you can have memory leaks. And these resource management consciously, a C++ programmer, or especially a C programmer, is much more aware about resources. Especially a C programmer has to actually take great care not to leak memory, because everything is explicit. And sometimes the APIs, even in the C standard library, are inconsistent who owns the memory. And that's just one of the many resources we have to deal with in real-world programming. So resource management is not easy. You can write whole books on that. Even the famous Gang of 4 design patterns book. Now, again, who knows about that design pattern book? Okay, at least know about it. It has a pattern called factory method, and even a thing more infrastructure like abstract factory, but it forgets about disposal. So if you acquire something through a factory, if that's a resource that you need to manage, you need the means to return it somewhere so it can be reused or released. And that's what Kevin and Henny wrote down about in 2004. And again, the Gang of Four design patterns book, there were some C++ programmers, but also Smalltalk programmers writing that. And they forgot about mentioning that, because in Smalltalk, as Java has garbage collection, memory is not a resource that you consciously acquire and release. You only recognize it's a resource when you build up object cycles that never get released by the garbage collector. And again, there's the manager design patterns in one of the less famous pattern books, the Pattern Languages of Programming. Number 3 has my pattern in there. And the manager design pattern encapsulates management of instances of a class. So read that, of resources into a separate manager object, allowing variation of the management functionality independent of the class and for the reuse of the manager for different object classes. That's a long thing to say is the manager has a factory and a disposal method. You acquire a resource by the factory and return it by the disposal method. So we always have these pairs of using stuff in between, keeping track of the resources. Now, C++, thankfully, has a very interesting facility that is the Curley closing brace. That's the most important syntactical element we need to be aware of, because that allows us to have a deterministic object lifetime model. We know when things pass out, or when they retired or returned or destructed. That's the correct terminology. So we have this cleanup, let's say the C++ global janitor curly brace closing, and destructors that automatically run there. And that's one of the cornerstones that makes C++ so efficient and effective for a lot of things, especially for resource management. And Bjarne Strostrup coined the term resource acquisition is initialization, and it should go further on, and running the destructor is resource release. So in the initialization, in the constructor of an object, you acquire the resource, and in the destructor, you clean it up. If you do it that way, you never can forget to dispose the resource as long as you don't leak your object's lifetime somewhere else and it stays there forever, like in global memory. Yeah. So scopes, closing curly braces, allow us to do resource management sanely and safely in C++. Even when you get exceptions or unexpected control flow, the cleanup runs always if you do it right. C++ 11 made it even more useful. Before C++ 11, the only clear, good cleanup was scope-based. So in a scope, you acquire a resource, and when you leave the scope, it's released. And that's what worked. There was a facility called auto pointer. Someone still remembering that? You're lucky if you don't remember that. Because it tried to solve a problem without having the language facility to do it correctly, and that gave very interesting bugs, and it was not recommended to actually use. Some people recommended it, and then others got problems from that. So, but in C++ 11, we get move semantics, and that allows us to actually not only have the scope as the environment of a resource, but having the uniqueness of the ownership of the resource, allowing us to return a resource from a function and having it clean up just once. There's a single authoritative owner of a resource. For memory, we have for that unique pointer, which is a replacement to auto pointer. And for other things, well, we have more. But now, why am I talking about this thing? There is a generic RAII proposal, and just a simple timeline of its life. And the blue bars is the number of classes in the proposal paper. The red one is the number of factory functions. The green's the optional factory functions. And if you look at that, it goes up and down. And many, many releases. So we are planning to get release number 9 by October for the November meeting in San Diego. It's not written yet. And it started out even before release number 0. So we have 9 existing releases with the P52 plus 4 previous paper, making it 13. And I'm not sure if we managed to not get to release A. I think that might be the first paper that actually gets a hexadecimal release revision number. Chances are high it gets there. When I wrote the proposal for the talk, I was much more optimistic. But optimism is one of the reasons why we still have that paper in flight. More on that later. So, but they are more than just unique resource that I propose in that paper. There are RAII classes in the standard that help us to keep our head sane. One could say anywhere where destruction has a side effect, where the destructor is not defaulted and not trivial, but that's sometimes it's used to cheat. But what we can definitely say, we have file streams, for example. There the constructor will open the file if you don't do any special things about it, and the destructor will close the file, release the resource, the open file handle to the operating system. That's a typical RAII magic happening there. We have unique pointer I talked about, but also string, standard string is a RAII. Usually you acquire memory when you create a string object, unless it's empty string. You might extend that allocated memory by extending the string, but whenever you destroy a string object, the memory gets released, so its cleanup is automatically. The same is true for all of the containers that we have. We have, since C++11 and later on, we have mutexes. And mutex is a typical resource where you acquire it, you use it, and then you release it. And if you forget to release it, you get big problems, like deadlocks or usually deadlocks. And if you forget to acquire it, you get even more problems, like data races, which means unicorns, rainbows, or whatever. So, any more from the top of your head? Oops, nothing happened. RAII classes. Thread a resource? It is a resource. Is the standard thread class an RAII class? Since I live in Switzerland, where voting is almost every other weekend, a quick show of hands. Who thinks, just from the top of your head, no thinking, just a feeling, who thinks standard thread is an RAII class? Who thinks not? So what's the magic in thread? If you don't join the thread, running the destructor gives you interesting effects. It's still initialized in the constructor, but it's not really, that's what's missing in the RAII. The cleanup is not in the destructor of thread. You have to do that explicitly, which gives a whole bunch of problems, and Nico Yusutis might talk hours on that with you. We might get a scope thread for that. Yes? There are proposals on making thread. The question is isn't there a joinable thread proposal or something that is actually an RAII thread? There is. It's not in the standard yet, but we might get it. Maybe it was voted in Rapperswil and I didn't get that, but it's not in C++17, definitely not. There's a little spoiler for tomorrow. Using RAII classes makes your code usually sane and safe, meaning that things just work well if you use RAII. And that's the topic of tomorrow's talk. Now, writing interesting destructors with side effects is something that I try to get my students not to do. But nevertheless, I have to show them that there is something as like a destructor, and the best thing is write crappy code and show them how to use that. And actually, the person guilty of that code example is sitting in that room right now, or is that from me? I'm not sure. Maybe. So a tracer class, a perfect thing to see that destructors with side effect can have, to actually see when destructors run. And that's the purpose of that code. And whenever I use a pinkish background, that's because that's code you shouldn't write at home. In my life, I've worked with complicated OO frameworks in C++ where classes like that were essential to understand how the framework worked, especially when you fucked up your code. So you needed, sorry my language, you needed tracing, printf debugging, because in multi-threaded code, running it in debugger is very hard to figure out what's wrong. And I would say interactive debugging is the worst thing a professional programmer can do. It's the biggest time waste. The only means, and there I'm with Niklaus Wirth, to run a debugger is have a post-mortem dump to analyze where the stack hung, where you get a deadlock or whatever crash in your program. Side note. But again, we are all professionals, so we know if there are rules given by a despotic trainer like me or teacher like me, there are always exceptions to the rules. Okay. There is one exception to the rule, or one thing where, okay, Java developers and others, like in C#, tend to want to have destructors that run at curly brace, and they didn't have that. So they invented something like finally. Now we have many programmers today, programming C++, who grew up with Java or C#, and they would love to have finally. We even have it in the C++ core guidelines support library. There are several other things I consider being a mistake taken over from C# and Java, like override and final, which I believe should never have made it into C++ standard. Debatable. See me in the breaks. We can have a fight. And the finally goes closely in that direction. I will have later some slides on that. But if you do need cleanup, resource release, use or write your own RAII classes. And that's one of the few places where you have a destructor that's not defaulted or just not existing, not specified, not declared. Most of your types should have either defaulted destructor or not declared at all, which is even better. People have fun. So unique pointer. Who has not heard of unique pointer so far in this room? Okay. There are people who propose unique pointer as generic RAII. My opinion is don't. A lot of operating systems or resources are represented by handles, which are trivial types, which might fit into a pointer or not. Sometimes there are even pointers. Unique pointer requires that your pointer type is a nullable pointer, so you can set it to null pointer, and you can compare it against null pointer. And usually when it's comparing equal with a null pointer, when it is a null pointer, the deleter function is not called from the destructor of the unique pointer. I've seen it, this example is copied from a blog post, and it's about a Windows handle. I'm not a Windows programmer, but I don't know. And I believe, fortunately, invalid handle value might be 0, but you never know. It might even be -1 cast to pointer, or 0 or less than 32, and you cannot compare a pointer to -1, so it's interesting to get what you get there. And the automatic running the deleter object in the unique pointer destructor is not actually working. So don't. There's another Stack Overflow question. I wrote an answer that is not the top answer yet. Unique pointer for file pointers. This looks quite innocent. You have a file, that's good, it's a pointer, and you have a function pointer that takes a file pointer and returns an int, which is the signature of fclose according to the standard library declaration definitions. You open the file and then automatically you close it. And the problem is this one. We are not in C. In C we don't have overloading. So taking the address of a function name, perfect, always works correctly, sanctioned by the standard. In C++, every function that is spelled out explicitly or implicitly in the C++ standard library, you're not allowed to take the address of that function. I think it might be worth a CppCon or a Cpp Now talk on why that is that case. Just believe me, it is not. And there are people on the standards committee who know, and yes. The thing is, it might be defined in your standard library implementation as a macro. It might have additional parameters that are defaulted for your usual use case. So the standard only allows you to call fclose, not to take the address of it. And the good thing is, the default value of a failed fopen call is a null pointer, and that's a nullable pointer. So file star is a nullable pointer, so at least the mechanics of unique pointer work. The original answer to that question on how to use unique pointer for file pointers actually refers to CPP reference, but it doesn't spell out the version of CPP reference. After people complained, no, CPP reference is wrong as well, that was easily changed to be correct, and they introduce a special function called close file in their example that calls fclose, which is sanctioned and good, and use that close file function, which is a regular user level function where you can take the address. In that example, it's not overloaded, so it's just work. So they use close file as the unique pointer deleter part. Another option is to pass in a lambda that calls fclose, which is also sanctioned by the standard. An even better version would actually create a class with the overloaded call operator that calls fclose, because that class could then be used instead of that pointer thing as the unique pointer's deleter object. And then if it's a class without any state, it's an empty base class, and you get empty base class optimization in the implementation of unique pointer, making the unique pointer as big as a file pointer, like the regular unique pointers are as well. I don't show that because that's, again, the same story, showing the deleter object for free, and that's another talk already. Now, what do we actually want to get to? Unique resource. That's a generic RAII wrapper, and it can be used for integer handles like file descriptors. Well, it's a little bit cheating because for files we already have file stream objects, but sometimes you might actually want to specify things that you only can do via the POSIX API that's given by C, like the open system call. You get a file name, some options, and the permission bits read-write for everybody. And you want to close that. And see, this is C++ 17 code. We have class template argument deduction. So the type of the handle and the type of the deleter object, which is a function, a lambda actually here in that case, is automatically deduced, and the corresponding unique resource is created. And to obtain the handle, you have to use get to get there. Get it. So you break the encapsulation. And that's where you see, okay, maybe that unique resource is some shady thing. Whenever you write get in code, in the standard library code, it means you have some breaking of encapsulation, of danger lurking. Unicorns around the corner, just around the corner. Okay. In April 2013, C++ standardization meeting in Chicago, I believe, Andrew Sandoval provided a paper number N3677, consisting of 4 suggested template classes: scoped function, scoped resource unchecked, scoped resource, and unique resource. The scope part is, in the classic sense, like scope pointer that we had in Boost for ages, cleaning up at the curly brace at the end of that. And his motivation was all the kind of handle things that they had in their systems were cleaning up, was a separate step, and whenever you got an exception, you have problems. Good. And some of the things in his motivation was, oh, unique resource, you have these const export deleter functions, whatever that means in that sentence. Actually, it was some kind of magic, so he could actually use the function pointer of the deleter function as a template argument. You can have you can have pointers as template arguments, like you can have integers, if that pointer is somehow global known at link time. And functions usually are global known at link time. Well, I was sitting in that review meeting in the, it was still, I believe, library working group. We didn't have library evolution then. And I said, oh, I'm a big head. That can be simplified. Now, that's a story of my simplification. This can be simpler. So I reduce it from 4 classes and 5 factories to 1 class and 2 factories. Cool, huh? I was wrong. Then I attended the talk by Andrei Alexandrescu, CppCon 2015, on uncaught exceptions and scope guards. Anybody been there? Seen it on video? Okay. Eye-opener. Yeah! We can have scope guards that do something interesting. I'm still not sure if it's too good to have them, but they are in the paper. So, uncaught exceptions, a new feature in C++17. The first compiler is actually providing it. Great, we can try it and play with it. Then came Eric Niebler, famous speaker here, and actually one of my master programmers, and he told me, well, this can be even more generic. I made the assumption of, okay, my resource types are handled. They are trivially copyable. I don't have to care about moving them around. It just works. And whoever does something bad with them deserves what gets what he deserves or what she deserves. No. Eric said, we can do it better. The thing is, it's quite hard to do it right, as you can see from the timeline. Then came actually compilers with class template argument deduction. Yeah! No more factories required, except for a single one that serves a specific purpose. If concepts for actually working, make even simpler. Even in the specification of the feature, we can use if context for, and I'll show you in a few minutes, how that is employed. And, nasty me, I found a bug in my own specification. Great. You see, that bug was in there at least half of the time so far. Nobody recognized it. It was about double releases, which is better not happening. Like double deletes, bad thing, unicorns. And I'm not speaking about the nice, fancy unicorns that little girls play with. I'm talking about Charles Stross unicorns. Anybody reading Charles Stross? Laundry files? There the unicorns are really nasty beasts. And then there was a library working group meeting in August this year. And here's some feedback, and I show it to you how that came back to me. I couldn't attend that meeting. Sorry for me. So my first attempt on making it simpler. I assumed sanity in template arguments, and that was the time when I just wrote the apply paper, or maybe it was even put in the standard in C++, 14-ish, 15. At least it was written, the paper, on having apply, that was an example for integer sequence, into the standard. Apply is call a function and take a tuple and pass all the tuple elements as the function arguments. Good. So, being a big boy, like all engineers that I train, usually the hardest thing that you just learned, you want to apply it in series. I applied apply. Again, implementation thought everything is well behaved. If you have multiple resources, everything works fine. Release is not a problem. And we have a single deleter, lambda, or function that takes all the resources as arguments and then does something. Well, it turned out that simple solution was too simple. Then came Andre. Oh, he said in the slides, no need to add a type for an occasional RAII idiom. Just scope guard it. Is that a good idea? Does adding a type actually hurt you? C++ has a very strong and interesting type system, and writing a type is not that much work. Even your IDE might create the struct for you when you spell out the type name, like ours does. Andre's solution used interesting macros. Who loves macros? The interesting macros is something I hate and all IDEs hate because they have a boundary of the macro expansion that is not a syntactical element. If the macro looks like a function call but isn't something that's syntactically an expression, it's very bad for IDEs to parse it well and represent it well internally. It's not impossible, but it's not nice to them. Be nice to your IDE, then it is nice to you. But he gave me the idea of having a scope exit that runs whenever the curly braces is there, a scope fail that only runs when you leave the scope with an exception, or the scope's success that only runs when you leave the scope without an exception. And the uncaught exception mechanics is actually what made that work. And for those who are curious, that's his macro on scope fail. And there's some magic happening, and it ends with the lambda that's half done, capturing everything by reference, which is dangerous, or at least surprising sometimes, and tries to do it well. So I was saying all resources are sane. Not really. If you write generic code, you don't know what your users pass to you, and they might not even do it intentionally. Just capturing something interesting with the lambda might end up making that lambda behave interestingly. So, what happens if a resource throws on move? That's a corner case where you can say, okay, someone who gets that gets what he deserves. That's not something you do like. That's not the nice unicorns, the bad unicorns. But maybe it might not actually move, but it might copy when you say, I want to move it. And copying might actually use resources. And if you can't get a resource, copying fails. And the interesting thing is, there is a nice query in the standard library called move if no except. The problem is, if that is not copy constructible, it will try to move anyway, even if move might throw. So if it's not copy constructible, but move constructible, but the move constructible is throwing, you end up interesting things. Or maybe my logic is wrong. But nevertheless, throwing moves are bad, and copying might fail. That's my story. So Eric, my programming god, came up with an infrastructure to safeguard against that problem. So he invented a box type where you can have either copying or moving into that type generically. And to actually construct that externally, you have perfect forwarding and a guard object that is released when everything went well, when the constructor body runs. And that's interesting mechanic, and you're not supposed to understand everything of it. It's just there. And the thing is, you need to jump many hoops for a fail-safe generic code, and that's the current version, and the original one, even it was by Eric, had some tiny little bugs in it that we found. So, how things fit together. There's that scope exit generic wrapper. It constructs an exit function object from the function that is passed in as the constructor argument. It's actually perfectly forward, and exit function is such a box object. And it gets a lambda or a function object that is run when this copying of the exit function into that new box object fails. And if everything is fine, nothing happens. That's also important, no double releases. And if you end that scope exit and it should execute the exit function, it's obtained from the box and run. And if it should execute or not is dependent on which kind of scope exit, scope guard you're actually doing. Either the scope exit, scope fail, or scope success. So if the move construction of the exit function succeeds, the constructor body runs and releases the moved from element, so it doesn't double delete. That's good. Otherwise, if the move or copy fails, you get the original intact. And if you don't understand what I'm just talking about, I might not even understand it myself. The message is, don't try at home. It's just hard to do that. That's the biggest reason why a thing like that should be in the standard library, so that the big brains are able to implement it and you just use it. Because doing yourself in a generic way, I learned it the hard part from my bravery in 2013. It's not simple or easy. Now, how can you figure out if you have a bug in that? You test for insanity in the template arguments, and you write never nasty code you would never write at home just to have your test cases that figure out the bad corner cases in your code. Like function objects that throw on copy or move, and all kinds of variations. Interesting. Resource objects that throw on copy or move, or even throw on move, and you don't want to have that. Resource objects that cannot even be assigned to, which actually checks the sphenae of the reset functionality, is it available or not, because you don't want to reset a resource when you cannot assign to the resource, which is not an issue with a simple handle type, but whatever resource you might put into that, it's generic. We don't know in that library the non-assignable resource. Now, to give you an example on how the complexity works out, fortunately, we now have if context, so we don't have to do overload resolution on enable if, so CNI around that thing, so we can actually write. If we have an assignment, a move assignment, we first check for self-assignment. That's essential because we don't want to prematurely release our resource that we hold. We release it by calling reset, which is no except. That's one of the guarantees we ask for by the providers. And that's checked with static asserts. If both parts of our unique resource, the resource and the deleter object, are no throw move assignable, nothing bad can happen. It just works. So we move assign them. If one of them is not move assignable, we first do the copy because that leaves the original resource, the moved from object intact. And then move the other part that is safe to move. So we get an exception before we put the other object in the moved from state. And if both are non-movable or no except move assignable, we copy both of them, where the original stays intact. And only then we actually set the other into don't destroy the resource, because then everything is fine. Otherwise, the original object stays in a means that it's not moved from, so it will actually destroy the resource. You see, we have 2 resources, 4 cases to deal with to be exception safe and sane in the move assignment. And managing just 2 resources alone that can individually fail to move or copy is almost insane to follow that. Just figure out what you get when you have 3 resources that individually can fail to move or copy or to initialize. Don't go there. Don't do it. So that's the reason why you should employ unique resource when wrapping your own resources or write your own RAII classes only for a single resource, not for multiple. Doing it for multiple is a pain and too easy to get wrong. Now, I promised you the bug in the specification. That's the specification of the move constructor. We just have seen move assignment of a unique resource. And who finds the bug? It's, again, the same trick. If something is move constructible without throwing an exception, we do the move. Otherwise, we copy. And the same with the deleter object. And if that throws an exception, we actually call the deleter with the already moved resource. And release the right-hand side, so it's no longer calling the deleter. And finally, we memorize that the execute on destruction was on the right-hand side. Anybody found this the problem? So you actually might not run the deleter when you delete the object. Yeah?
Yes, if you manage to copy the resource across, but you don't manage to copy the deleter, then nothing's removable, so everything has to be copied. So you get a copy of a resource, but then the deleter can't get copied. So now you only have one deleter, the original one, that can delete the original resource. But you didn't manage to get a second deleter to delete the second resource?
No, you don't copy let's say you don't duplicate the resource. You move the resource, the move constructor, but you run the right-hand side deleter in that case and release it. So the resource, even that copying the resource, the moved from resource is okay, and you cannot copy the deleter, you still delete the resource because everything boom. But the bug is, this code doesn't consider if the right-hand side was actually needing to delete the resource. It was unconditionally deleting the resource, and that's the bug there. If the right-hand side was already released, there's no work to do. And this would cause a double delete. So only when the right-hand side needed to actually clean up, the cleanup is done. And you see the node is extended again. This mechanism ensures no leaking and no double releases, which is not too easy to spot. It took more than 10 revisions to find that. How do you test for such nasty things? That is a test case. It violates all good software engineering practices, but it's only for the test case. And it actually has a deleter object that throws on the second copy. On every second copy, but it's only used once and in that test case. But actually that made that test case fail when you forgot that thing. And I wrote that test case to make sure we never introduce that bug again. And you see, don't do that in production code. But who has not seen things like that in production code? Global state. Never ever? Lucky. More surprises. We got a feedback of BSI that asked us to add that node. If the exit function of a scope success or scope exit object refers to a local variable of the function where it is defined, e.g. as a lambda capturing the variable by reference, and that variable is used in a return operand of that function, that variable might have already been returned when the scope guard's destructor executes calling the exit function. This can lead to surprising behavior because it might be moved from state and you access it expecting it having the original state or some state at all. You might even call a member function that you're not allowed to call on it when it's in a moved from state. And I tried hard to figure out a version where it works. And fortunately, the implementation of the string class that I had a destructive move. But you have to guarantee that it's actually copied or moved. And that's by the parentheses I put around the return. Never ever do that at home because it hinders all optimization of copy elision. But what you expect would be that the length that you pass back from the access returned from string function is actually the actual length of the string, but it isn't. It's 0 because you access the string in the lambda of the scope exit guard only after it has been moved from. So the cleanup of the string object is not done yet because the sequence of the variables, but it's moved from the return statement already has been processed. So you get this test case passes. And remember, Andre's macro passed all variables by reference to the lambda there. Danger lurking, or let's see, it's not unicorns, it's more like, oh, there's a flower there. I didn't expect that. A nice one or a stinky one? You don't know. Final feedback. You're not supposed to read that. Just all the pinky parts is where the feedback, the protocol that was taken, has some ... in there. I have not figured out everywhere what ... means. Sometimes it meant mumble. I don't understand it. Or maybe I wasn't fast typing enough. I wouldn't say that the Notetaker is guilty. It's just, it's very hard if you're not present to make use of the feedback you get from the working groups. So you will not see that anywhere else. So I'm sure the reviewers and the Notetaker did their best. It's just not easy to process that. And especially because it's so an intricate, tricky feature, you very often get feedback that is opposing in different meetings and maybe in the same meeting, which also tells a story about why it's taking so long. What's left? Oh, we could do things like empty base optimization if we have empty deleters to make the unique resource object smaller. We might get around that with the no unique address for the deleter object. At the moment, it wouldn't work, but maybe we can, I'm not sure if I let's say I leave that task to the standard library implementers. At least that's my take today. Nodescard, we cannot use Nodescard on constructors, which is a pity, because especially the unique resource and the scope guards, especially the scope guards, you want to have Nodescard on the constructor, because if you don't declare a local variable, it's like immediately calling the lambda or the deleter function. That's not what you want to do. Like this. And I need to incorporate the final feedback, especially the standard is a moving target. All the section names of specifying the behavior or the semantics of a library function have changed the name and sometimes even split the semantics. So that's busy work to getting the spec according to the current rules in the standard. Now, should you write your own RAII wrapper? In my opinions, yes. It's good to do your own abstractions. Don't cheat. Even if Andrew says no need to add a type for occasionally RAII idioms, I think there's no thing that is occasionally. Either you code this deliberately and then do it right or not. On the other hand, things like finally or scope exit, they have a smell of a hack. Maybe sometimes you want to stand that smell, but not that often. Don't sprinkle it into your code base. It's like you need raw pointers in C++ to implement things like unique pointer, but you don't want to have raw pointers in your own code base. And this is the only example from Andre about kind of transaction semantic where you remove a temporary file that you no longer need when things fail, or that's partially written. But that's a nice code. You don't have to do try-catch and things like that, but I'm not sure if that's that common. And it's nicely encapsulated in that single function and not spreading in your code base. I'm happy to learn more about using scope guards like scope fail throughout your code base and being happy with it. Andrew seems to be happy about it. I'm not sure if that's really the best thing to do in all the cases. Now, what should you take away? If you don't know RAII, learn about it and use it consciously for all kinds of resources that you acquire and have to release in your program. Understand your own resources. Like, what kind of resource is it? Is it a shared resource, which is rare, and incorporates all kinds of problems if sharing means you mutate it from different places, which gives you data races without the protection? What life cycle does your resource have? Is it local to a scope? Do you have to extend the life cycle of the resource, keep it around, like with the unique resource that return from factory or pass along the call chain up and down? What amount of resources need to program? That's always a problem. I know of server and apps that just have to be restarted. A good server runs 24/7 for years without having the need to restart. I've created software like that with my teams. It's not easy, but the ops people love you for it. Generic resource. Oh, maybe I have to say, oops, sorry. I've been to a conference 2 weeks ago or 3 where people were saying, yeah, you get memory leaks and stuff like that. No, in C++ you don't have to. And if you write code that has memory leak, you're doing bad things. Don't. We have the facilities to easily manage that it works. And that's true for all the resources, RAII. Do it. There's no excuse at all, and that's not even me being despotic, to have leaking code in C++. It's hard if you do more than one resource. But using a thing like a unique resource or other RAII wrapper, you can easily combine them as members in a class. And there the semantics of C++ using constructors, if constructing the object fails halfway through, all the cleanup is done automatically for you. There's no try catch required. It just works. In your own classes, wrap each resource member acquired individually in a RAII wrapper to achieve that transaction semantics on failure of one. And do not naively use scope guards throughout your code base. Build proper RAII abstractions. Beware of pseudo-dangling references removed from variables in these lambdas that you run on scope exit. And the teaser for tonight, tool time. We demo our IDE. We have a couple of hats and some Swiss chocolate as well to give away. So if you can stand up as long, I'm not sure if I can make it 8 something. I'm not sure if it's 8 or 8:30 tool time for development. If you have other questions about that, feel free to contact us and go for it. So, oh, that's not what I wanted. Questions? Use a microphone, that makes it easier to record it.
Yeah, so one of the main cases that I've seen for using this, and I've been dreaming about it for years, and that's why I'm following your proposals, is for interacting with legacy SQL. Because what you might think of as a resource as files or database queries or some big resources, most C code really works by some initialization and release functions. Now, if I understand your resources correctly, you have several things that kind of make converting legacy C code into properly managed C++ code, it really uglifies the code. Because first of all, you have the get, and I would really love to have at least a policy for implicit conversion, especially if you have a wall of API. I know this is controversial. Yes.
We had that, and it got removed.
Yes, well, I would really want to at least have a wrapper that uses that.
Tell the committee.
Yes. And the other thing is, I think having the deleter as part of the type is really problematic if you're trying to keep a C resource as a number. So you want something that behaves like a C pointer. But if it's in the type, it's very difficult to initialize.
I think someone will answer that question for me.
I'm going to answer that. It's not a big issue because there will be a type going into a standard library called function wrapper, which is a type reference, a type erasure for functions that has reference semantics. So if you use a stored function wrap in place of the deleter, then you get all these unique resources of the same type.
Well, the thing is,
you don't own the deleter in that case. If you want to own deleter, use this two function.
so maybe let me summarize. There was an issue about, okay, making the deleter part of the type gives you problems because you have too many types then. There is type erasure available coming or in 20. And in addition, and you can use parse the deleter by reference. That's one of the corners I didn't explain to you because the talk was too long already. You can actually pass a reference wrapper, or actually you can pass a reference to a function and it will or keep a reference wrapper around to some of that.
That is also a type issue.
Yeah, it doesn't solve the type issue, but the reference wrapper is another dimension of complexity that I didn't talk about today. So there's more lurking. So.
Okay, my comments. Can you go back to a slide showing the lots of if concepts first?
I don't get that.
There's a slide showing if concepts.
Oh, that one. Oh, the
Concepts for if.
Yeah. No. The one with the many cases.
Yeah,
that one. Okay.
To be honest, this is a bad use of the concepts. The reason is that it duplicated the conditions, right? There's one condition is no throw move assignable that is against box D is duplicated. This line is the same as that line, right? So what we should do here is to create a bool constant dispatching. So you have a function that accepts two bool constant arguments, and you dispatch it against two conditions, so that you have 4 overloads at taking true type, false type.
Have you seen the code how it was before?
Yeah.
That's exactly how it was. And then someone suggested using if context.
No, well, this piece is not going to go into the specification, right?
Well, the specification is as if, and it's easier to specify with if context, but you don't have to implement it that way.
Implementation-wise, I would use bool constant dispatching, because I never want to do
You're free to do that. I think we need to catch up. Time is over, but maybe one last quick question, or?
I don't know if it's going to be quicker. I mean, basically my comment was just, you said, I'm not sure how common this is when you were talking about what Andre did. I feel a little bit the opposite in the sense of like, sometimes I've used ScopeGuard for years, and I sometimes get mileage out of it for ad hoc, not very often. The issue with all this is that, I mean, you said yourself, like, yeah, usually the resource is a handle, you can just copy it, and like, usually, actually the deleter is just stateless, and you don't even have to think about moving it. So I've written many of my own RAII classes, and I've actually personally never encountered a single case where I had to think about any of this. It was always actually very easy to write yourself. So, I mean, I know everyone writes different code, so I'm just curious, like, how many times are we actually going to be in cases where writing the RAII class yourself is so hard to do correctly because you really could throw every time you move, which is, I almost never see that in general. It just seems to me like a very, very tiny corner case. And like, you know, ScopeGuard, an immovable ScopeGuard, like just the lambda taking version that's immovable, could have easily been standardized in 17 because it's like 10 lines of code, and once you can't move it, it's dead easy. And that's it. And I don't know. That's what I've seen.
That was my opinion 5 years ago as well.
Now you don't think so anymore.
Well, I was told otherwise.
Okay, cool. I'm just curious.
Library Evolution didn't like it that way, and I think thank you very much. See you tomorrow or tonight.